Hello, AP Environmental Science students. This is Mr. Harrison here. Today we're going to be talking about human population growth. I want to begin our journey with the Worldometer, current estimate for world population. You can see this number is a dynamic number. It's changing. It's an estimate based on UN data. We know that to calculate population growth, we have to look at birth rates, death rates, and immigration and emigration. Some other questions hopefully are arising when you think about this is which countries, which part of the world are growing too fast, contributing to this population growth? Which ones are not contributing? You might be thinking about your own individual reproductive choices. How many children are you going to have? What is the total fertility rate of different individuals across the globe? You might be wondering, what is the carrying capacity of our Earth? Can we support? We know right now that we're living unsustainably. Literally, can we support 10 billion people, 20 billion people, 50 billion? What is that number in terms of how many humans can this planet support? Well, today we're going to find out. And how we're going to do that is by looking at some data. So we're going to learn how to analyze some data, and we're going to be doing it in a couple different ways. So Puzzle 11, that's where we're at. We're going to be looking at age structure diagrams. We're going to be looking at total fertility rate, human population dynamics, and demographic transitions. You should see that our skills are going to remain the same, looking at patterns of data and drawing conclusions and looking at trends. So our instructional purpose today is to look at age structure diagrams, total fertility rate, human population dynamics, and we're going to learn about this process called demographic transition. Mainly looking at lecture, but we're going to have some FRQ and some multiple choice questions embedded in this Edpuzzle. Why we're doing this is, if you remember back to our first couple of weeks together, and we talked about how important it is to understand models for impact. And one of the ones we looked at is this equation, I equals P times A times T, where P stands for the population. And to understand our global impact on the environment, on the Earth, we really need to look closely and carefully at those populations, human populations. Okay, so to begin with, 3.6 age structure diagrams. Our objective is to look at those diagrams and just be able to interpret them based on their shape, also to be able to look at some of the data and make some conclusions. So here are some age cohorts. You should pretty easily be able to distinguish between countries that are expanding rapidly, slowly, stable, and declining. You should also be able to see that these bars represent different groups of people based on their age. So we call 0 to 14 the pre-reproductive age, 15 to 44 reproductive, and 45 plus post-reproductive. So you should be able to distinguish between those and also know some examples of countries which would fit that model. So when we look at expanding rapidly, we look for a big base here of pre-reproductive. Those are children, and those children will quickly step into reproductive. And we know that populations are going to be growing quickly. Expanding slowly, you can see there still is kind of a Christmas tree pattern here, less extreme. Stable, they call this kind of like a house. It looks kind of like a house. And the cohorts are pretty comparable in terms of the numbers. We do have countries like Germany, Bulgaria, and Russia, which are declining, meaning they're having less children now than they had before. And you can see they have an aging population. Okay, let's see if you can distinguish between the highest to lowest growth rate in these four different examples: India, United States, China, and Germany. All right, let's see if you got it. That was the order, actually: India, US, China, and Germany. Now, can you determine the number of 0 to 14 individuals pre-reproductive? So that would be the dark green bands. If you add those together, and this might be a problem you would do with a calculator, you would get numbers such as India has over 360 million people, children, right, that are in that pre-productive age. That is a little less than the US population. just in the 0 to 14 group. Okay, now as an FRQ practice for you, identify the country with the slowest population growth rate and explain your answer. Good luck. All right, 3.7, total fertility rate. Here we see a graph, and we're going to be doing some graphic analysis and looking at how that's changed over time. So we're going to explain the factors that influence total fertility rate. TFR is the term you want to remember. And we're going to be talking about it in terms of reproductive replacement levels. And we're going to talk about factors, and those factors are going to include things such as infant mortality rates, if women have access to healthcare, nutrition. We're also going to be talking about cultural differences and how those all influence the total fertility rate. So total fertility rate, TFR, is the average number of children a woman in a population will bear through her lifetime. The higher the TFR, the higher the birth rate, and of course, the higher the population growth rate, generally. There's a term called replacement level fertility, which you should be familiar with. And this is the total fertility rate required to offset the deaths in the population, keep that population stable. Typically, that's in developed countries, 2.1. In developing countries, that number can vary. It can be a lot higher. Keep trying to have that 0.1 child. It's just not working out. Now, that's an average number, so 2.1. Infant mortality rates are going to be a big factor here, and that's the number of deaths of children under the age of 1. And this is usually in less developed countries where there's lack of health care, there's lack of clean water, and enough food. I told you a little bit about my experience in Paraguay, and in those examples, in my experiences, I saw women lose the children, and it was really sad. And oftentimes it related to not having access to clean water. A higher infant mortality rate usually means a higher TFR, and that was true in Paraguay, where women would often have many children to kind of replace those children they might have lost earlier. And for agriculture, we're going to be talking about that as a major reason women or families will have more children. So here are two maps, and you should see some correlation between global total fertility rates and those countries that have high infant mortality, especially sub-Saharan Africa. You can see a darker color in both cases. Here's a graphical comparison, so infant mortality rate over time and children per woman, or total fertility rate over time. And you should see both are declining, which is really good news for the earth and for people's quality of life. And why this is happening is because we have more access to clean water, healthcare, vaccines, vitamins, supplements, more reliable food supply. We're going to be talking about that here shortly. So factors that influence TFR, one of the biggest is development. So as countries become more affluent, they tend to have less children. This usually has to do with women having access to educational opportunities, economic opportunities, higher access to family planning. Women often delay their first pregnancy. And also as countries develop, we're going to be learning, they tend to be less of an agricultural based economy, and there's less of incentive to have those children working in the fields. So urbanization is a big part of this development. Government policies can also play a factor. Examples are China has had one-child policy. Now it's two-child policies. There have been examples both in China and India of forced or volunteer sterilization. We're going to be discussing those different techniques in terms of ethics. There have been tax incentives to have fewer children. In some countries, currently, in Germany and some other countries, they're trying to incentivize people to have children. Also, a big role can be things like micro credits or loans, specifically for women to start their own business. And oftentimes, those women have more capacity to do other things other than have children. So you should be able to see here in this graph the influence of affluence on birth rates or total fertility rates. So here, each one of these dots represents a country. You can see the average income. This is GDP per capita. And you can see that with an average income going higher, you see less and less birth rates. And that is access to educational, economic opportunities, leaving less room for raising children, more access to contraceptives and family planning. We'll be discussing that as well, and typically lower infant mortality rates. Here is a really graph you should be able to see, and that with the names of different countries, the average years of schooling of women in reproductive age and what impact that has on children per woman. So more education for women especially means fewer unplanned pregnancies. More education means more job opportunities. Really, women are able to kind of take charge of their own lives, which in some countries that is not necessarily the case. So having education is powerful. Okay, here's what I'd like you to do is identify and discuss two of the causes for the trend in worldwide total fertility rate over time. Describing patterns in data. Okay, 3.8, human population dynamics. So to begin with, I'm going to talk about this Thomas Malthus and his theory in the early part of the century in terms of what was going to happen to the Earth. And Malthus hypothesized that we're going to run out of food. If our current population growth continues, our population is going to exceed that carrying capacity on a global level. And we talked about this earlier, what carrying capacity means. And then there's going to be this catastrophe. That was what Thomas Malthus believed. So we're going to come back to that in a second. Explain how human populations experience growth, decline. We're going to be talking about a lot of different essential knowledge. I'm not going to read all these, but we're going to have some are going to be more quantitative. You can see we're going to learn how to calculate how long it would take a country to double at a given growth rate. I think that's a kind of neat trick. So Malthus, back to that, we're going to run out of food. Human population is happening faster than growth of food production. Humans will reach a carrying capacity limit by food. So this is kind of what was predicted to happen. We'd run out of food. We'd have a deficit in the lot. Millions and billions of, millions, hundreds of millions of people would starve to death. Fortunately for us, or unfortunately, fortunately for us, humans can alter the carrying capacity of the Earth. And one of the biggest things that happened in the turn of the 1918, back to the nutrient cycles we talked about earlier, their ability to remove and extract that nitrogen directly from the air and fix it synthetically and produce fertilizers. We also did a lot of selection for different traits in our corn and our wheat and other rice and other crops, and we dramatically increased our food production per acre. And that obviously allowed us to support more people on this planet. So significant improvement in agricultural technology. Something to remember, make sure you write that down in your notes. Okay, exponential increase in food supply. You can kind of see this in our three big crops, wheat, barley, and oats. And we're going to be talking about this in the next unit. We're going to be talking about food production. And this is in the UK in production. These are all called cereals, wheat, barley, and oats. All right. So how do you calculate growth rate? How do you figure out how fast a country is growing? How do you figure out how fast your investment's growing? Some of the math is kind of similar. So growth rate, R, is the percent increase in population, usually per year. Here's an example of a growth rate of 5% for a population of 100 means they grow to 105. So that would also meet the monetary example. If you had $100 and it was earning a 5% interest, again, it would accumulate to 105. So accrued birth rate and death rate. CBR, these are other abbreviations you need to know, CBR. So birth and death rates per 1,000 people in a population. Here's an example. Global crude birth rate, CBR, equals 20, and CDR equals 8. So how do we calculate exactly how fast the population is growing? We do a little math, and we do the crude birth rate minus the crude death rate. We divide by 10 so we can get our percent, and you can see there our percent is 1.2. So this example would be growing at 1.2%. So there it is there, divide by 10 because CDR and CDR are per 1,000. So we have to get this to percent per 100. So we have to divide by 10. Right. Here's a neat trick also if you're investing some money or you're trying to figure out population growth, is called the rule of 70. So this is the time it takes in years for a population to double, is equal to 70 divided by the growth rate. So once you figure out the growth rate of a population, so if we take an example here, we just talked about 1.2%. We want to figure out how many years it will take for that population to double. We simply divide 70 by that number, and we see 58.3 years. So this is the global population. This is based on, I think our number is pretty close to 1.2. It might be 1.1 global population growth will double in 58 years, according to this data. So rule of 70 is a neat trick to learn and make sure that you are going to be looking at some examples when we meet in class and have you do some math together. Okay, here's a practice problem. Country has a CDR of 9 and a CBR of 18. Calculate the annual growth rate and the doubling time. Let's see how you do. And yes, you can use your calculators. It's highly recommended, in fact. Push those buttons. Good luck. Oh, there's a solution. So a solution, you should have gotten 18 minus 9 divided by 10. You get a growth rate of 0.9%. You divide 70 by that number, and you get a doubling time of 77.77 years. Okay, factors that increase population growth rate. So higher TFR means higher growth rate. Higher infant mortality rate can also drive up the replacement fertility rate. We talked about that. Immigration. So a high immigration level is going to start increasing population growth. Increased access to clean water and healthcare can have some impact in increasing populations, but we're going to learn that isn't always it doesn't stay that way all the time, but does decrease death rate. And we're going to talk about what do those people do once they decrease death rate. We're going to learn that it actually decreases usually their fertility. They usually have less children. So here we have factors that increase the growth rate, high death rate, high infant mortality. We talked about development, education, affluence, delayed age of first child, and postponement of marriage can also have a decreasing impact. Other factors, standard of living. So what's the quality of life is also a big factor. GDP, we talked about this at the beginning of the year. Gross domestic product is a key economic indicator of standard of living. And we use that to kind of measure the economic wealth of a country or a person. We'll look at per capita. Life expectancy usually is a key indicator also of standard of living. This is how long you will live in a given country at birth. Typically is when they estimate that population. And of course, clean water, healthcare, and stable food sources are all going to have an impact and be a good indicator. Higher GDP and life expectancy are both great indicators of development and of usually countries are growing slowly. Here's an FRQ I'd like you to practice. Describe one environmental problem associated with rapid growing human population and propose a solution a government could take to slow the population growth. Good luck. Okay, 2 more units here. 3.9 demographic transition. So you should be looking at this graph here and saying, hey, what's going on? We got stage 1, stage 2, stage 3, and stage 4. Up here we've got birth and death rates. You can see there's a distinction between birth rates and death rates down below. And then how fast is this population growing? So what's the natural increase? So take a look at that graph because we're going to be coming back to it. You can see birth rates here. You can see death rates here. Total population over time. Okay, so we're going to define what demographic transition is and kind of try to estimate, try to guess where different countries are in terms of this demographic transition, and look at the characteristics of those countries and those different stages of transition. So industrialization is a big factor in this process, where economic and social transition from an agrarian, which is farming-based economy, to an industrial-based, manufacturing-based economy. We have many countries in this world that are still considered pre-industrialized. They haven't quite made the agrarian to industrial transition. They tend to be very economically poor, have a low GDP, high death rate, high infant mortality, high TFR for replacement and for agricultural labor. Industrialized or industrializing or developing countries are almost there. They're partway through this transition. You tend to see decrease in death rates and IMR and rising GDP. And lastly, industrialized countries. You can see their characteristics. So development status, we talked about less developing countries and developed countries. And of course, there's a gradient all the way through. So this gives us a breakdown of developed countries like the United States, all of Europe, see Australia, Japan. We have countries that are developing countries, and we see them that are above Saharan Africa, South America, Mexico, most of Asia. And then this distinguishes what are called the least developed countries, and most of those are sub-Saharan African. Stage 1, so those pre-industrial countries, so that would be the ones that are least developed. We just talked about have a high infant mortality rate, high death rate. Again, clean water, stable food supply, healthcare are all limited. There's also lack of education for women, contraception, need for children in agriculture. Typically, their population growth isn't super dramatic because due to the high birth rate and death rate balancing them out. But there's currently no countries considered in this phase, stage 1 pre-industrial. So 100%, there would be 100% agricultural societies. And most countries we know have urban areas, and they have some economic development that is not agricultural based. So no countries really are fitting into this stage. Stage 2, and we do have some countries that are doing this where they start to modernize. They have clean health, clean water, healthcare, stable food supply. See a decline in birth and death rates and infant mortality rates. TFR still remains high because usually it's lack of education for women, contraception, need for children in labor. There's usually a generational lag. So in order for things to change and societal changes need to happen, first there's a time period between the economic change and the societal change. They tend to have a rapid growth rate due to high crude birth rates and declining crude death rates. When you look at them, they tend to have low per capita GDP, short life expectancy, high infant mortality, high total fertility rate, low literacy rates, and school life expectancy for girls. So usually oftentimes it's an issue with lack of women's rights. Stage 3, these are modernized economy and society, increased family income. So total fertility rate tends to decrease. And this is because there's more opportunities for women to educate, delay their marriage, first child. They have access to family planning. Usually what happens, there's a slowing growth rate as crude birth rate drops closer to crude death rate. So there's that lag that happens. Economic societal indicators usually are they have a high per capita GDP, long life expectancy, low infant mortality, total fertility rate near 2.1, high literacy and school life expectancy for all. Okay, last one. Stage 4, post-industrial, highly developed. These countries are very affluent. Total fertility rates continue to decline because they're wealthy. Increased wealth and education brings even more prevalent use of family planning. Crude death rates oftentimes go even lower than that crude death rates, and growth rate becomes negative. So there's an actually decline in population in that country. Economic society indicators, you can see them very high GDP, long life expectancy, low TFR, highest contraception use. So you put it all together, and here we've got our stages of this demographic transition. So be familiar with this graph and how it represents total population growth rates through the different stages. Understand the relationship between death rate and birth rate through those stages, how that's going to influence population growth rate. Back to what we talked about, the visualizing growth rate in those population pyramids, and how they correspond for those different stages. Okay, FRQ practice 3.9. Identify the stage of this graph in which this population grows the fastest and explain why this is the case. Describe one economic or social indicator country in this phase. All right, that's it. Good luck.